Hello everyone, this is Caplitero and welcome back to a new episode. Today we're going to talk about Sfml again and how to create your own cube because Sfml doesn't have a 3D library and I was really bored and I wanted to try something new and yeah, let's do it. Start a new Sfml project, call this cube. Yeah, already I have to try my code line, don't I? Uh, okay, resource, header, window. You can check it works. I'm not going to do something very complicated. I'm just doing the normal perspective. Like you won't see any depth in it, but you'll see a cube. It's working. So how are we gonna do this? Paint, like usual, and size. Let's say this is our cube. This is a face and our cube. We're gonna numerate this and you'll see that the most distant point in the cube from our view is this point, but the closer you are to the screen, you can see all of them. If they are all in the background at the same distance, you don't see them, and if there are only two, we can see this. Okay, so how are we gonna do that? New header file, new header cube class, like usual. Create a class for cube. Here, what am I gonna do? We're gonna say the faces. So, let's first of all create our own vector. Let's call this struct vector 3D. Let's create a vector D constructor load of x, y, z is equals 0, I equals 0, and z equals 0. Vector 3D of load x, load y, load z, and say x program a, I, and z. We have our own vector. Now, what we're gonna do, create the faces. Let's say, let's use stream and include a vector. I'm gonna use vectors. I don't recommend them, but they're quite useful for something small. Let's say vector std vector. We're gonna make a 2D array of int. Let's say faces, and here we're gonna implement our faces. Let's say I shouldn't have done that, but paint. Okay. Let's say we have this, 0, 1, 2, 3, 4. Okay. So we're gonna add all these points, all these faces. 0, 1, 2, 3, 0, 1, 5, 4, 5, 4, 6, 7. So let's keep our paint here and let's go 0, 1, 5, 4. We're gonna have 6 of them. Oh, okay. 1, 2, 6, 5. 1, 2, 6, 5. Let's go 2, 3, 7, 6. 3, 0, 4, 4, 7. 0, 1, 2, 3. And last one, 6, 7. 0, 1, 5, 4, 0, 1, 0, 6. I hope they're all right. Here it's actually 3 because we have 3, 0, 4, 7. 0, 1, 2, 3, and 4. Yeah, I hope so. Now, let's create a public constructor for the cube. We're gonna use a size, and we're gonna get the distance from the center to the edge. So let's call this load center distance equals 0 for compiler, and see this equals size divided by 2. Because in a cube, everything goes from the middle, from the middle, it's half there. Okay. With this vector, we can actually initialize our points in space. Let's see. Yeah, I have a file right here, but it's because there's a lot to write and I don't remember all of it. So let's say vector 3D of vertex. There are 8 points in a cube. And let's say vector of -1 means it's in front of the center, so this. Then we're gonna go 1 down, so again minus, because the screen goes yeah, actually went no z x the left of it, so it's minus, down, so it's minus because of y. Actually go up. What did I write here? Oh, I wrote it upside down, that's why. And z because it goes in the back. I'm gonna copy all of them. These are all the points for the cube. Go left, front. Oh, I actually created in 3D, so go down and in front of That's why. What else I'm gonna use? Here I'm gonna implement this. Yeah, no, I done that. And let's see. We're gonna use some vectors. Public. Gonna use vector 3D of its pointer for all the points. Load of distance from the view to the point. What did I? Oh, okay. And an std vector. Std vector of int. Here we're gonna use this to show every face. So we have a vector. The vector is this. This is a face, a face, a face. So we're gonna show the points we use. Let's initialize our cd new vector 8 because there are 8 points, and distances. Uh, we're gonna use a different distance. This is an exterior use for distance, or if you use with other projections or other curves, other objects, and this is a vector of a float, I mean, with all the distances of the cube from our view. And I'm gonna show you nice quick a new load of 9. Why 9? Because I'm gonna in the 8th spot, in the 9th spot I mean, we're gonna put the max position, because as I showed you, we can't get all of the faces. The max of them is 3, and you don't see the most distant point. That's the point. I'm gonna show the 8 is the max distance, and some points can have the same distance from the view, thus you can see them in only one face. Okay, I'm repeating myself. I'm sorry if I do that. Okay, I'm gonna show you some tricks with rotation. But now let's draw. Let's actually make a vector for move. We're gonna say void of move, and this will be null because we're gonna set the angle points in space for int I equals 0. All the points cd of I equals center plus vertex I times the distance. Let's put the distance up here. Okay, why I'm doing this? So it's because this is the center, and as I've told you, it goes in directions -1. This is, I showed you, -1, -1, I. So we go 50%, the half distance there from this point, half distance there is here, 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 here. So why the center? Because we're gonna put the center, the cube in a place. Depending on its center, it will be, this will produce the points let's say we're gonna use an operand function. Vector. It will return a vector operator plus a vector 3D vector, and we're gonna return a vector 3D, but with new position vec point x. Wait. Is the problem? Return what's the problem? Plus x and then load uh 1 second, guys. XYZ. Yeah, I don't get it. Vec times I plus y and vec z plus z. I don't know what's that. And actually, let's create one more problem. This is the same thing. I'm gonna take this and add to the first one. No, let's say vector because I'm gonna need operator time. The 3D vec return vector 3D vec this float a times a times a z times a. This is everything. This is all we're gonna do with vector. I hope so. What else are we gonna use? The move function we've created. Oh, the center. Let's call the center right here. It's a vector 3D. We center with the initial point 0, 0, 0. This. What else are we gonna do? Float size. Okay. Gonna call move to create our cube. We're gonna put all the points of the cube in their required point, in the required space. I should. Okay. Gonna multiply the vector. It can be a smaller distance because we are gonna convert all of this. And let's say this point gonna be smaller. And that's because I'm gonna show you how to rotate it, and it's gonna be super. What else are we gonna use? Oh, float of distance in 3D space. Float, let's say vector 3D of view and vector 3D of object. This is the point from where we're viewing, and this is the object. I mean, it's the it's actually the point, but it's easier to calculate. Load. Why do I spell like that? Load xcv. This is x cubic because we are gonna take this to the hierarchy of 2. I'm not using pow because I'm not going into math. This is actually, no, x. Okay, I'm gonna have three actions, I and z. Oof. Okay, and we're gonna return security, let's say f of CB plus ICB plus ZCB. Okay. This will return the distance. What else? We have rotate. Not that, I mean, I'm gonna use it. Let's say draw. No, let's say move to a different space. Void of move, float x, float I, float z. Let's remember that this is point of our center. So center will be converted to x, 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 y, z. And I think we can all move. Yeah, because let's say move to the point. What else do we need? Rotate, not yet, distance 2. This will be distance from our view. Not yet. I'm trying to show you guys. Let's say void draw. X float y. Z. This will draw to the view. This is the view coordinates. We're gonna clear the show. Update or distances. Update distances to the vector 3D x, y, z. What is update distances? Well, we're gonna take what to write? Let's write it here. Void update distances with vector 3D of view. So we're gonna take every point and we're gonna calculate the distance from our view. Distances of 8, I told you this is the maximum, equals distances of 0, because we are calculating first of all from let's call this maximum. We're gonna believe that 0 is the maximum point, most back in the back, and we're gonna check if the rest of them are bigger or not. Plus plus. Okay, we start from 1 because 0 it's already calculated. We're gonna check if distances I mean calculate them first of all. Calculate distance. View and CD3 of I. Calculate distance, check. I told you that we're gonna use dist from outside because we are gonna convert this to a more useful argument. So we're gonna have distances of I, and if distances of I is bigger than the maximum 8, oh, what we're gonna do, set the maximum to distances of I. And I forgot here to put distances. To make this the more we're gonna see, this is in the front, yes. This is the most in the back, the further away. So this is not, we're gonna see that this is the most back way point. I'm sorry for my English. Trying my best, guys. And let's see, I equals 0, smaller than 8, I plus plus. And we're gonna check if our points are the further away, the most further away or not. Okay, distances of I equals the maximum, because I told you there can be more points in the maximum zone, equals distances I equal 0. We're not gonna use this point to show, but we're gonna use the points that we can see, distances I equals 1 times I plus 1. Okay. I think we can just do this. Okay. What are we gonna do with this? So convert the points in 4, 5, 7, 8. Convert the points with one more index, because if we set to I, it will be 0, and at point 0, we're gonna use 0. Yeah, I think we can use this, but 0, it's not, I mean, yeah, it's useless. Okay, so this will convert the points. Now in draw function, vector 3D and and distances. Oh, okay. In our draw function, after we calculated our points, we'll see. So let's say create a new one. The points in the front, let's say this is 0, 1, 4, and 5. These points will have values of 1, 2, so this is actually 4, it's 5. No, oh boy. Okay, 1, 2, 6, and 5. And we're gonna see that other points will have 0 because we can see them. And that's the value we can see. The value we can see will be -1, representing the point. So we're gonna do that for int of face, because we're gonna have 6 faces. 6 face plus plus int of index 0. Faces means up here where we set our faces. We're gonna check all of them. How? Int of corner 0. Corner will be 4 because we have 5 corners, and 5, 4, what? 5 corners. And index will be plus faces of face corner minus. So we're gonna check this one. So 0, 1, 5, 4. We're gonna have 0 first of all. and we're gonna subtract the distance that we converted of faces of face. What's the problem? Oh, and the corner. Yeah. And the corner. Did I in here? Corner. So 0, 0. We're gonna check the distance at 0. The distance at 0, let's see, distance at 0, it will be 1. We have 1, yes. Now, because we have 1, we're gonna divide it to 0, and 0 minus 0 will be 0. If we have point 1, it will have distance 2. 2 minus 1 will be 1. 1 minus 1 will be 0. We'll calculate this for all the points. Let's see what's the problem. What's the problem? Specify, I think here. Yeah. And it will be outside. Let's close these ones. They're useless. And we're gonna see if index, they're all the divisions will push back our face. So if we have, if you can see all of the points, it means we can see the face, and we'll put the face in the view vector, so we can convert it to a rectangle in the future. Okay. What else do we need? Let's say the distance 2, because we're gonna use this to, let's make it better. From the view, and we're gonna return all distance between center and vector of 3D x, y, z. What else? Why do we do that? Because let's make this bigger. Okay, we have points. Okay, this is the center. If we want to move, we'll have a start position and an end position. And we can calculate this view from the center. What else do we need? Let's say rotate, the moment of truth. Float alpha x, rotate alpha x, float alpha y, and float alpha z. Okay, we're gonna have rotate of x, alpha x, rotate of y, alpha y, and rotate z, alpha z. What are these functions? We're gonna write them right here. Let's start by void rotate x. I'm gonna use an angle. We can call it alpha, angle, whatever you want, and we'll take the sinus of angle, float of cos, sin angle, I mean sinus, and for all the points in our cube, we're gonna convert them to a new position. So I equals vertex I times love x z vertex I z. What are those? These are coordinates. I'm gonna draw again. Oh. And the this is quite hard to get. Took me a lot of time, but this is x because x goes this way. This is x, the plane of x. This will be z because the plane goes that way. You can move this plane, and I will be this plane because I goes up and down. So yeah, that's all of them. And why do we use these functions? Because if, let's say, we want to rotate this, as I showed you, this is the z, and we can rotate on the z. It will go whoop, whoop. If you want to rotate on, let's say, x, x goes this way, and we can rotate there. And if you want I is on this plane, and we'll rotate this. So I, Z, and X. It's easier to understand. What do we have here? Where's the problem? Float. 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 Okay. Whoa, 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 whoa. And what are the functions? Well, vertex. We're gonna convert our vector points. I times cosine of f minus z times sinus f. Gonna have z plus I times sine f. Cosine. With this function, it's a rotate matrix. You can check. I don't know. Let's see. Oop, 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 oop. Rotate matrix. Rotation. Oh, okay. Rotation matrix. I don't care if you saw my history buttons. This is sinus, and you can see x, but we have I depends on the x and y. Yeah. 1 second, guys. Okay, I'm back. Just had a small problem. Rotate of y load, but I'm gonna just in paste because we're gonna have three functions I and z. I will be the same one, but gonna have x and z. X we're gonna convert to x. This will be reversed. Plus plus. one problem again. Okay. There was some noise and I didn't want to disrupt the video. We're gonna convert this to the move because we change our points, and we're gonna do void rotate as I changed the one x x x x everything else plus 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 and minus except okay. Here we're gonna have x and y. You can see that when we rotate, it's not seen here because we're gonna change the coordinates on the plane of set. So we're gonna have points here. They're gonna go on this plane. You're gonna rotate on it. Okay. X, Y plus and minus. Everything else, anything else, anything else. It is so I here have an X here a Z. Here we're gonna have an X. Anything else? I don't think so. Let's check if it wrote everything all right. Set. I hope this is working. I don't think there's anything else to write. The distance we did, move we did, vertex, center, structure, the faces, and the draw cube. What did we add to the cube? The move function we did. Okay, anything else? The move function. Rotate. Oh, distance to and rotate. We did it. And alpha. This is everything for the header class. Now we're gonna go back here, add our new cube class. Gonna create, let's see, I'm using again hit so I don't do something bad. Gonna have the cube because I don't have a constructor. Render window, position Z. This will be the screen, the Z position, and we're gonna see it from the screen. We're not gonna go in space too much in this video, but we're gonna have, as I told you, a vector of 2i of mouse start. Can I start? Can I write properly? Okay, and a mouse end. Gonna move it with our mouse. Anything else? The mouse, because Sfml uses mouse. And a vertex array for a cube. Really. Gonna have a function called calculate distance. SF vector y will be p1, and SF vector 2i of p2. What we're gonna do with this, it's calculate this distance. Okay, float of xcb, like we did in past. P2, why did I write it in? P2 minus P1 P2 amount X times P2 minus P1 X. ICB, it's the same thing. We use I. Do I say it right? It's I return load colors. Why did I write it 0? I don't know. I'm I'm not saying what I am. Gonna have SQRT. I don't think we're gonna use it, that's all. SQRT of ICP plus ICP. I think I didn't use it, that's why. Void update. In the update, we're gonna have let's go to start. We have to initialize all of this, and it's quite a lot to do. Okay, the window, I'm gonna have cube, new cube. Let's say the size of 100 pixels. Cube, no, 2D. What was cube 3D? Cube 3D. That set primitive will be SF quads. Cube. I'm gonna move the cube to the width of the screen, to the height of the screen, and let's say minus 100. We'll go back a little. Okay, and cube draw. We'll do a this is our view. And do we have anything yet? Yeah, 0. Because this is our, let's say, what do you call it? Position Z. That's position. Okay. Cube 3D, we're gonna resize it to cube show size. Or the size is how many faces we have. Do we have one face or 3 faces? And every face will have 4 points. You can see where I get. Or we're gonna initialize. Do I want to initialize it here? Let's add it in the update. No, let's actually make void update row. Okay, for int I equals 0, I cube show cube show. Wait, what? Oh, sometimes my genius quite frightening. Show size a plus plus. It could have been a big problem if I didn't see that vector of int. This will be the face. Let's say face ID cube of show that let's save our face the face we have here, but is the face saved in the beginning? Did I write? Is that with here? If index pushback. Okay, what else? SF vertex of face. We'll use cube, cube 3D, type 4 for int j equals 0, g equals 4, j plus plus. This is the corner. We can call these corners, but yeah. What about, let's say, face of j times position equals SF vector 2 of cube, with a cube t of face IT of g. This is time x, and we're gonna have one more for the I. We can actually wait. This is a vector 3D. No, I can. Okay. Let's say if we're gonna have something to, we can actually visualize it. J times color equals SF color 0 to 55 0 0. This is the first phase, second, third. Let's say 0 0. Now we finished this. Let's see, what else do we need? Okay, this is the last part, and I'm finally done with it. Here, it will have a function type SF event mouse button pressed. We'll have a, let's call this bold, a equals 0, okay, equals 1, and our mouse position will be SF of mouse get no, mouse get position. Okay, we're gonna loop k equals 1. So if we still have our mouse pressed, let's say event type equals a save event mouse released, okay, equals 0, because we're gonna let loose of our mouse. Let's see, what do we have here? Oh, it's 2 times, okay. So here we're gonna have mouse end equals mouse at get position of according to the window, regardless to window. Float the x equals mouse end times minus mouse start x. So the I equals mouse minus mouse. Gonna have load of distance 0.1 equals cube of distance to mouse start x, mouse start y, load distance 0.2 2. Actually, we don't need 2 because I'm gonna have a float alpha x. I'm gonna find the x between x p1 load alpha I equals a10 of pi p1. What's this? It's p1, this is the start, p2, this is the origin, and we're gonna have this alpha. How are we gonna find this alpha? We're gonna divide the opposite, I don't know what's called in English. Anyway, call this T, no, I mean, it's P1, P2, P1, P2 divided by O, P1. This is the tangent alpha equals, and we're gonna have arctangent equals arctangent of P1, P2. Yeah, I'm sorry if I can't explain it quite in the useful way. I'm trying to make a video, and you'll actually, if you work with them, you're gonna get why they work, how they work. I'll make a separate separate video about this, I hope. But now I'm gonna rotate alpha x, alpha y, alpha x and 0. Leave this for the moment. Cube row. Gonna have window get size x by 2. Y divided by 2, and ink position z. Yeah. What else you're gonna use? This is a window cube draw, and now we can just cube 3D point resize cube times show size times 4 and mouse start equals mouse end. Everything should be working. Here and here was a problem. Mouse distance 2. This will be of size of position. See. We're gonna wait for Sfml like usual. Oh, I forgot to draw. Window, draw, cube 3. And here we're gonna update the draw. Let's check. What's the problem? Okay, we have one more problem. What's the cause of this position? I think it's from here, actually. Let's let's check this real quick. In I show I++, face ID, show I times 4, JJ. Okay, this is all. Oh, this is quite frightening. Wait, I'm gonna cut and we'll get back right there. I'm back, guys. The only problem I've had to look through it was that I wrote everything like this. I'm sorry for my voice, but my head hurts. And I that and I actually added one small minus here because it is reversed. The I it's not in this position, it's down. And now you can see our cube is moving, and I've used all of those functions to create a cube that only has 3 faces all the time, and you don't have to generate all 6 of them at the same time. Because you can see if I go right here, can I? It's not possible. But if you look in the past, can I look in the? No, I can't. Oh. It's actually a jump in the memory when we start. Let's see, because right now we have hold on. I'm just bad. Anyway, you can see oh we have 107%, and the moment I move it doesn't change. I guess I broke it. Oh, oh. Anyway, thank you for watching, guys, and I hope you found this video useful. I was trying to make something interesting these days, and I'll work with perspective too, so we'll have smaller lines here. But for now, I think it's all good. Thank you for watching, guys, and see you next time.